A lighthouse is a simple tool that's been valuable for centuries. It keeps mariners safe, even on a dark and stormy night. A lighthouse directional radiation detector shares these characteristics, shedding light on locations of radiation sources.
Locating a radiation source with traditional radiation detectors can be challenging. First, they can only guess at a source's location by indicating if the radiation signal is getting stronger or weaker. And second, they are easily confused by widespread sources or when multiple sources are present. Los Alamos National Laboratory has brought 75 years of experience in radiation detectors to bear with the design of the Lighthouse detectors to solve these technical challenges.
Lighthouse detectors are a broad class of directional radiation detectors that share a common design. For our detector, we start with a conventional detector that receives input from every direction. Then we wrap it in an attenuating material that blocks radiation from every side except one. This limits the detector's field of view to a narrow beam, much like the beam of light from a lighthouse. We can move or rotate the detector, and it will give a maximum signal when it is pointing at a source. The attenuating material also blocks background interference from nearby sources, like volcanic rock or even the potassium flowing in the user's blood. This blocking improves the sensitivity for detecting a signal by dampening out the background noise.
Specific technical features enhance lighthouse applications. Power and communication can use either USB or Ethernet, making the lighthouse detectors ideal for remote field applications. The built-in graphic interface on our detector can be accessed by any computer with a web browser. The computer interface supports customization so users can tailor it to support their particular applications.
Due to the design simplicity, it's easy to underestimate the impact of lighthouse detectors. Now that we can precisely identify the location and movements of radioactive materials, many capabilities and applications have become possible. We can verify location and quantity of radioactive materials in storage containers, a useful application for taking inventories. We can sense movements of radioactive materials through doors and hallways. The detector could be connected to alarm systems to alert when materials enter or leave designated areas to keep them secure. We can reveal the presence of radioactive materials in surveys, waste, and the environment, and enable targeted cleanup.
Scientists from Los Alamos National Laboratory and 3 industrial partners have taken lighthouse detectors to large-scale production and real-world applications. Working with Questa Instruments, Phoenix International, and Sexton Corporation, they created models of the detector tailored to meet specific applications, such as locating sources of gamma rays, thermal, and fast neutrons.
We are working with national security and emergency responders to explore automated mapping of complex sites. Data will be sent in real time from first responders to experts in radiation at remote command centers, keeping first responders and the public safe and minimizing radiation exposure. In a demonstration at the Trinity Nuclear Test Site, we showed all of these emergency responder capabilities in operation. Mapping radiological sources at the Trinity site could be a first step in returning this space to the public National Park System as part of the Manhattan Project National Historical Park. We also have demonstrated effectiveness underwater. Our submersibles can survey radioactive materials to depths of 7,000 meters. At that depth, we can survey 99% of the ocean floor. Lighthouse detectors are also a new tool for basic science, such as geological surveys of naturally occurring radioactive rocks. As we get more requests and hear new application ideas, we realize these detectors still have untapped potential.
With the Lighthouse directional radiation detectors, Los Alamos continues to leverage its decades of radiation expertise to identify national security threats and keep the nation safe. Their directional gamma and neutron sensing are improving safety and security at production and storage facilities. Robots and first responders can use wireless lighthouse systems to reduce risk and human exposure during emergency response. And the submersible lighthouse systems in the ocean depths demonstrates the flexibility and robustness of these detectors in harsh environments. Welcome to the world of the Lighthouse detector, the new beacon of light leading us into safety, security, and knowledge for clear sailing into the 21st century.